Today we're talking about polynomials and multiplying terms, specifically looking at distribution and an area model that will allow you to keep track of all the multiplications that we have to do. But let's get some definitions taken care of first. The first definition we want to talk about is polynomial itself. That's just an expression with more than one term. Now remember, a term is anything that's separated by addition or subtraction. So if we're looking at these examples right here, this is a monomial because there's only one term. Then go ahead and figure out what you think. If it has two terms, what should be called? Right, it should be called a binomial. And then if there's a trinomial, an example of a trinomial, go ahead and write one. An example of a trinomial might be x squared plus 2x plus 2. So, to multiply polynomials, there's two main ways to think about it. And some of you already think about it in terms of the distribution model. Distribution just says if we've got a number outside of the parentheses, when they're smashed together like this, that means we multiply. But there's two terms inside. One term, two terms. So there's going to be two multiplication problems. And distribution just says I've got to multiply, got a text, negative 6 times x and negative 6 times negative 3. And negative 6 times negative 3 is positive 18. Negative 6 times negative 3, so it's negative 6 plus 18. Oops, I goofed up there. Negative 6x plus 18. That's the distribution model, and that works for some of you. But we're going to look at the area model right now, and that is a visual model that allows you to keep track of stuff. And the area model kind of is like a multiplication chart. So the area model says that this part is going to be one of the dimensions of the rectangle, and this part is going to be the other dimension of the rectangle, x minus 3. And then we're going to go ahead and fill in the boxes based on like a multiplication chart. So negative 6 times x right here is going to be negative 6 times x. And then negative 6 times negative 3 is positive 18. And then you just go ahead and see if there's any simplification or any like terms. In this case there is not, so we get negative 6x plus 18. Same thing we got the other way. But the idea with the area model is each piece is part of the dimensions. So the nice thing about the area model is it gives you a way of keeping track of your multiplication problems. We're going to look at this particular one, which has two terms here, 1, 2, separated by that subtraction, and another two terms, 1, 2, separated by the addition. So now we're going to have 4 multiplication problems that we have to keep track of. So what the instruction tells us is we're going to go ahead and use those terms as the side lengths of the binomial. The binomials are the side lengths of the rectangle. So we're going to go ahead and look at this, and I'm going to pick a little green here. X minus 7, I'm going to write like that, and then x plus 8 on the other dimension. And then we're going to go ahead and just keep track. We're going to put the product of each problem in the box, thinking like a multiplication table. So x times x is x squared. X times negative 7 is negative 7x. X times 8 is 8x. And then 8 times negative 7 is negative 56. So now you have your 4 multiplication problems, check. We're going to go ahead and look for like terms. Remember, like terms have the same variable and the same exponent. So most of the time our like terms in an area model are going to be right there in the middle. So we're going to simplify this now. Remember, we could write it as 4 things: x squared minus 7x plus 8x minus 56. But instead, we're going to simplify it by making it as easy as possible to read. So we're going to go ahead and put the x squared plus 1x, 8x plus negative 7x is 1x minus 56. So that's how we deal with that one. We're going to also show this same exact problem using the other method, and then we're going to come back and practice each one. And by the end of this, you're probably going to decide which method you like better, and that's fine. When we do the opposite of distributing, we're going to use the area model going backwards, and so I would like you to be familiar with both of them, but I'm going to introduce both, and you kind of get to decide which one you prefer. Okay. So go ahead and move to the other side of this, which shows the other method. Basically, distribution is distribution. When you have multiplication on the outside of a parenthesis, you have to multiply by everything inside. Well, in this case, we've got 2 terms and 2 terms, so we're going to have 4 multiplication problems. You got to keep track of it. So an acronym like FOIL helps you keep track of those 4 multiplication problems. And once you do all 4, you combine the like terms and write in descending order. We're going to talk a little bit more about that in a moment. But here we go. There's our first term right here, x times x. And then here is our outside term, which is 8 times x. Here is our inside term. Be careful with that negative sign. I'm just going to write it as negative 7x. And then last, we have negative 7 times 8. You notice I don't like subtraction, so I tend not to deal with it as much. Once you've done that part, first outside, inside, last, then you can go ahead and combine any like terms. Once again, like terms are the ones with the same variables, and when you do FOIL in this order, they're always the ones on the inside. So here we go. We have our like terms. We're just going to go ahead and write this in descending order. Descending means that the highest exponent is first, and then add it again, plus negative 7x is 1x, and then negative 7 times 8 is a negative 56. Descending order, biggest exponent, next biggest exponent, constant. Okay, so now we've done the FOIL method, or the acronym method, to keep track of it. Now we're going to do another and another, and then you get to decide what you want to do each time you're presented with binomials. We're back to the area model, so we're going to go ahead and remember that we're going to make the binomials, once again, 1, 2, 3, 4 terms. We're going to make those our dimensions. Go ahead and fill them where you think they go, and I'll wait a second for you. I'm going to write in green 2x minus 2. Now it doesn't matter that this first one is here or the second one's down there. That's not important. But it is kind of important if that you put your x's on the corner. It's just easier if we all do that the same way. It's just kind of an agreed upon thing. It's not a big deal, but it's just agreed upon. So then we're going to go ahead and do our multiplication. 2x times 3x is 6x squared. 3x times negative 2, negative 6x. 2x times 5 is 10x. And 5 times negative 2 is negative 10. Then we're going to go ahead and look for our like terms. They're right here in the middle. I'm going to move that up so we can go ahead and write this in descending order. 6x squared. A 6x and a negative 10x is going to be a plus 4x minus 10. We're going to do that with the other method, and then we're going to practice a lot, and you get to decide what method you like the best. So here we are using the first outside, inside, last. Here's our firsts. Now I'm writing it as the multiplication. Excuse me, that was rotten. I'm writing the actual multiplication problem down, but a lot of you can keep it in your head. So you can go ahead and go 2x times 3x is 6x squared. You're more than welcome to do that. The outsides are the farthest edges, and in this case it's 2x times 5, which is 10x. The inside, the inside is negative 2 times 3x or minus 2 times 3x. Both are perfectly okay. I just don't like subtraction. Minus 6x, and then our lasts are the negative 2 times 5. And that's just going to be a negative 10. Here's our like terms. We're going to go ahead and write it in descending order. Biggest exponent first, next biggest exponent, and then the constant. Same exact answer as we got the other way.